Hello everyone, my name is Fei Wu. I'm a PhD student at the University of Minnesota. The paper I'm going to present today is comparison of audio and visual cues to support remote guidance in immersive environments. Collaborative guidance is a form of immersive collaboration. Immersive collaboration in virtual reality integrates multiple located and remote individuals to interact with each other or share information in a virtual environment. It can be used to offer users instructions during activities in a virtual environment. It has a number of emerging applications, such as social entertainment, commercial activities for remote consumers, surgical simulation, distance learning, architectural design, and training in dangerous situations. In certain applications, it may be useful to facilitate collaborative guidance. Navigation is a fundamental interaction task in virtual reality. We employ navigation to explore environments or reach target locations. Most VR applications were designed using a first-person perspective view, which provides users with a strong sense of presence. However, users who only have a local first-person perspective view may lack of global information about the environment. It may increase difficulty during navigation of an unknown environment. Without accurate spatial information, users can hardly determine the location of a target and may waste their time on non-optimal paths. Although some navigation aids were proved to be helpful for navigation aid tasks in static virtual environments, they were not enough for dynamic virtual environment. In a complex and dynamically changing environment, it is difficult for the users to receive real-time information about the environment using only static navigation aids. Collaborative guidance can offer users instructions in real time during the tasks using a global perspective, such as a map-like view of the environment. Collaborative guidance requires technology-mediated communication. The specific modalities and the implementation parameters of the system will influence the performance and effectiveness of the task. However, much of the previous research has focused on exploring different variants of a single communication modality, such as visual cues. Relatively few studies have been conducted to compare the performance of multiple communication modalities to support collaborative guidance for navigation tasks in unfamiliar dynamic environments. We would like to research the performance of AR visual overlays and audio instructions to support the collaborative guidance in a navigation task in the real world. Audio instructions are the main technique used in collaborative guidance tasks nowadays, but AR technology is not mature enough to support such design with current generation technology. Therefore, we utilize immersive virtual reality to simulate future augmented reality capabilities. We present a study to compare performance of different communication modalities to support collaborative guidance in navigation tasks in dynamic virtual environments. In the experiment, participants served two kinds of roles, guiders and explorers. Three conditions were designed regarding the mode of communication between the guider and the explorer: audio only, visual only, and a combination of audio and visual cues. We designed a collaborative user interface and a virtual reality scenario for evaluating collaborative guidance tasks using these communication modalities. We conducted two studies, a didactic study conducted at a large public event and a controlled lab study. In the experiment, the guider was in charge of sending instructions to the explorer via a user interface. The 3D user interface includes two parts. The left part includes 10 audio buttons. The guider used these buttons to send audio instructions. The right part is a bird view map of the virtual building. The red circles are virtual overlays. They are invisible by default and can be activated by the guider. The map also indicated all the information that are needed about the environment, such as the position and orientation of the explorer. Here's a video shows the process. This part is the map is the guider's view, and this part is the explorer's view. The virtual environment was designed based on an architectural floor plan of a real building. It has complex hallways and rooms to explore. We also designed the virtual environment to be dynamic by adding 3 sentries. They wandered in the building randomly and had a broad field of view in all directions. The experiment included several trials for each condition. In each trial, the guiders need to guide the explorer to reach the end waypoint in the shortest time and avoid being seen by sentries. The explorer was required to navigate in the building, following the instructions sent by the guiders. We evaluated the performance of the 3 conditions in 4 criteria: navigation duration, sentries duration, easy to use, and effectiveness. Navigation duration was the amount of time that explorers spend to finish all tasks. Sentries duration was the amount of time that the explorers were viewed by the sentries. The data of easy to use and effectiveness were collected by a feedback questionnaire. The feedback questionnaire contains 2 parts. The first part includes 6 ratings, 2 for each condition. For each condition, it asks if the condition is easy to use and if it is effective for the guidance. Participants were required to rate their feelings using a 7-point Likert scale. 1 represented for strong disagree and 7 is for strongly agree. In the second part, participants were required to describe the factors that made the task easier and the factors that made the task more difficult. There were also some free response questions included to gather comments and suggestions. Our hypotheses were as follows. The combination condition would have better performance compared with the audio or video condition. It would result in shorter navigation duration and sentry duration, and be rated easier to use and more effective. The first experiment was a didactic study conducted at the Minnesota State Fair in 2019. It was a public event in a large environment. In each pair of the participants, 1 played the role of the guider while the other one served as the explorer. This is the procedure of the experiment. Participants need to fill in the pre-questionnaire, perform 1 practice trial and 3 formal trials, then finish a series of post-questionnaire. This is the result. For sentries duration, the statistical analysis showed that the combination condition had significantly better performance compared with the audio condition. Although the combination condition also showed better performance compared with the video condition, there was no significant difference between them. In the feedback questionnaire, the combination condition was rated significantly easier to use compared with the audio condition, but there was no significant difference between the video condition and the combination condition. The analysis of effectiveness has similar results. The analysis of experiment data was consistent with free questionnaires, replies, and all observations. Participants stated the factors that made the task more difficult in the audio condition and video condition. For the audio condition, some guiders explained that it was easy to become disoriented when they were looking at a bird view map. Also, it was difficult to describe the direction with just left or right comments in a complex hallway that consists of several directions. For the video condition, although waypoints were useful to get rid of disorientation problems for the guider and easy to recognize for the explorers, some explorers missed the waypoints which shown behind or next to them. Most participants described the combination condition as the factors that made the task easier. The first experiment was conducted in a large public event, which was uncontrolled with some interference. Both the guider and the explorer were played by participants. Therefore, we conducted a lab control study. Compared with the first experiment, it has a quiet environment with very little interference, a trained confederate to act as a guider, and longer experiment duration. The equipment, virtual environment, and user interface were the same with the first experiment. The procedure was also similar to the first experiment, except that the number of formal trials was increased to 12. The results were similar to the first experiment. The combination condition has significantly better performance in centuries duration compared with the audio condition. In the analysis of the feedback questionnaire, the combination condition and the visual condition have significantly higher rating than the audio condition in both criteria. We received similar responses in the three questions of the feedback questionnaire. Participants stated the factors that made the task more difficult in the audio condition and visual condition. The disorientation problem in the audio condition still existed even the guider was trained. Participants also reported that the audio comments were hardest to follow because it would not always cue at the exact right time and were not clear enough when they stood in front of a fork road. The drawbacks of the visual condition were also concentrated in looking for the waypoints. The factors that made the task more easier still concentrated in the combination condition, since it can well overcome the shortcomings in the single modality. In both experiments, although the combination condition shows better performance compared with the visual condition, the difference was not significant. This result is related to the Colavita visual dominance effect, which is a phenomenon that occurs when participants fail to respond to the auditory components significantly more often than the visual components of a bimodal target. We are interested in further exploration in sensory dominance effects in the context of multimodal remote guidance interfaces. If the Colavita visual dominance effect can also be observed in this context, then this would lead to a valuable insight into an effective design of future remote guidance interfaces. Additionally, our virtual environment was designed with zero interference, which may not apply in many real-world applications. In future experiments, it would be valuable to design scenarios that include background noise or other type of audio interference. Additional factors will also be introduced to provide visual interference, such as dynamic obstacles that block previous accessible paths. These factors may weaken users' abilities to rely on single navigation cues, which would provide an advantage for multimodal interfaces. Further experiments conducted using dyadic or confederate-based designs will also be considered to evaluate other communication modalities or 3D user interface to support collaborative guidance in immersive environments. Here comes our conclusion. In this study, we present three communication methods: audio only, visual only, and combination of audio and visual cues. We'll apply them in a two-user collaborative guiding navigation tasks in virtual reality. Two experiments were conducted: a dyadic study at a large public event and a control lab study using a confederate. Statistical analyses were conducted using task performance measures, including navigation duration and century duration performance, and questionnaire responses. In both experiments, the combination of two modalities has outcoming performance compared with only using audio instructions. That's all. Thank you.